Guys, so boys, oh, you're back. You two are back. Boys, you two move. You sit at the front now. It was definitely you two and another one, but for now, just you. Einstein, you're back. Ayush, you're back. So, guys, majority of this first section, we should already know. Element. If you remember, I would select a pure substance that cannot be further chemically or physically separated. You could also say same type of atom. Again, what does same type mean, Brad? Huh? I heard same sign. I hope it's not you though. What does same type mean? I mean, same number of protons. If you change the proton, you change atomic number, and you change the element. Cool. What a compound, and you know my definition that I taught you last year as well, that I definitely taught last year. Where's Prahas at? Prahas, you remember what I said? Last year and in year 7 I taught you this. Year 7, you were the motivated kid, I remember. 2 more different elements. Chemically bonded. On the phone? Someone on the phone now. I tell you once, if you get a phone, if you want your phone next time, I'm not going to say it. No, the only 3 people I'll tell to get off the phone, and it's you 3. No, only one. Arav, happy? Yes. Arav, you're the only person I'll keep telling get off the phone. You should thank me, Arav, for actually caring. No worries. Okay, 2 more different elements, which means H2 is not a compound, it's 2 of the same. Chemically bonded means ionic, covalent, and so on. Fixed whole number ratio. Whole number means no decimals. Fixed means water is always H2O and absolutely nothing else. Water is always H2O. Cool. Easy, basic, we're chilled so far. Formula is how you'd write stuff. We should know this by now for sure. If I write CaNO3, 2, and if I write this, write down on your paper, I give you guys 30 seconds. How many calcium, how many nitrogen, how many oxygen? Don't write it. Let's erase that mind. Let's erase that, Sam, and let's think it again. 2 CaNO3. 2 Ca. Guys, okay. Let me make it easy. Do it from this sound. Seems like the other one no one was going to get at this rate. Chris, put it away or I take it. I'll go back. So, guys, in this, I already know everyone's as good as you. No one thought of it. Guys, how many calcium now?
1.
How many nitrogen now?
2.
No, Sam, I had 2 in front. I got rid of that because you kept saying 1. 2 nitrogen, good. Krish, how many oxygen? Good. Guys, what I'm trying to prove is, if you have a bracket and you have a number outside the bracket, that number applies to everything inside the bracket as well. It's exactly like math. If you say 2 lots of this, which means I have 2 lots of this. Guys, tell me. How many potassium, how many P, and how many O? Write down. I don't want to hear it. Chris, I don't want to hear it. I don't want to hear it. Oh, I don't hear that as well. Its actual name where it comes from in Greek and Latin stuff. Okay. Boys, come talk. Boys. Yes, what do you mean? How many potassium? Yes. Guys, okay, good question. This 2 means 2 lots of all of this. We get it, Sam? 2 lots of K3PO4 means 2 K3PO4. It's assumed. Guys, if you have a number at the start.
That means it's 2 lots of K.
Yeah. Guys, if it's a number at the start, you assume it applies to everything. So, someone tell me how many potassium? 6. Good. How many phosphorus? How many oxygen? Cool. Guys, in this formula, Ayush, how many you in a fair bit? Ayush, how many carbon? How many hydrogen? Sure?
Yeah.
How many oxygen? Good. So, guys, important. Boys, okay. It's just the boys talking now. Most girls pay attention. If some aren't, I don't care anymore. Boys, stop talking. Arian, listen. I said stop talking in that second you made a noise. Raj, hello. Tell me, are compounded mixtures the same? Hello, Raj. How are you?
Good, thanks.
Raj, tell me, what's the difference?
Compounds are chemically.
Good.
Physically.
Good. No. We have 3 Raj in this classroom, do we? But no, Sam, you're correct. Compound, chemically. Mixtures, physically. Cool. That's the main difference. By physically, I mean physically combined in a variable ratio. Okay. What does variable ratio mean? It basically means this. If I have a mixture and I take a cup and take it around a bit and I look at it, that bit might be different if I take a mixture from a different part. That's what variable means. It's variable. Arian, what is it? Leave on your desk. That's the main difference. Mixture means not bonded. Okay, I thought it was obvious. Okay, guys, when things are physically mixed, they're not bonded with each other. Okay, chemically bonding means bonding. Physically just means I mix them like a mix-up. That's exactly what it means. Okay. I can separate them using things you learned in your first week of year 7 science.
Year 7. Year 7.
First week of year 7 for public schools, you got in separation of mixtures. Guys, if there has been a chemical change Several things can happen. Thing one, new substances are formed. If I mix iron and sulfur, this is new. Guys, who doesn't have a booklet?
Yeah, it's not in a
One. Books? Yeah, books. Chris, can you go tell Twinkle at 21 books, please? So, important. That's one sign of a chemical change. Press, stop talking. Of chemical change occurring. Alternatively, you could have energy taken in or out. Taken in basically means the surroundings might get colder. Released means they might get warmer. They're called endo and exothermic reactions. I'll do endo-exo in term 4. This one is mid, but apparently it exists. Apparently, the change is difficult to reverse. Some things you can change, other things you won't be able to change. Okay. Guys, just some things to know as well on reactions. Guys, assume this. Stephen, where are my reactants and where are my products? Good. Guys, do not write an equals to sign. Do not do anything fancy like draw an arrow like this, okay? It will be a stupid way to lose marks. A single arrow like this with a line is all you have to do. Physical change. No chemical stuff has been bonded. No chemical things has been made. You might see, by the way, change of color technically is also signs of chemical change. Change of color, a new gas has evolved, everything's a sign of chemical change. Oh, that's exactly what they say. Guys, okay. We have 40 minutes. We're doing one thing. I have to teach ionic bonding in its completeness in the next 40 minutes. Do not talk. If you want to go on your phone, fine, do it. I don't give two craps anymore. Arif, not you. And not Krish whenever he comes back. Do not interrupt me when I'm teaching ionic bonding. In fact, I should not have to teach any of this if you paid attention last year. It is the exact same thing I taught last year to my year 8s, wherever I did year 8s with. It is arguably the most important topic in all of year 11 chemistry, ionic bonding. If you know ionic bonding, you're pretty much set for chemistry, because ionic bonding, you got to know about ions, you got to know about electrostatic attraction and everything. If you want to pay attention, I'm more than happy to teach, ask any questions away. Please do not interrupt me. If you want to talk to the person next to you, it better be at a whisper. To the point where I cannot hear it. Otherwise, we are not getting through this much in the next 40 minutes. Have your pick. Okay? I'm not going to go off the book. If you're on the book, I mean, by all means, go for it. The book teaches the same things, but I'm going to teach everything my way. Okay? Why does stuff form bonds? Bonds are generally just attractions between atoms, okay? As generally as you speak it, it is attraction between atoms. We just started talking. It's ionic. Yes, Jeremy, I know it is. When I said whisper, and if I can hear it, that's not a whisper, is it?
Yeah.
Then maybe we shouldn't talk. In fact, you and I can go downstairs for a quick chat if you want. Huh? Yeah. No, if it's something very important, like Jenny, if something's happened, you guys can go. In fact, Jeremy, I think you've done it in school, if I'm not mistaken. Ionic bonds. Jeremy, we'll ask you now. Generally, what's the point of forming bonds? What is the point of forming bonds? Yes.
Like atoms have opposite charges, and then they opposite charges interact. So.
Okay, cool. You are correct. It's to achieve stability. Second week, and this is what's up. Where's my what? No, I'm playing. No, I'm playing. That was someone else. So, ionic bonding. Arif, please get off the phone if you're on your phone. So, this is what's up. Before we do that, what's an ion? I just go for it. I can't even hear Irish for some reason. You were leaning into Prahas, which obviously means Prahas wasn't gonna who's gonna talk to you, right? What were you gonna do then? Why was he leaning into you then, huh, Prahas? It's Valentine's Day, doesn't mean you do it here. No. He's leaning into you, which means what were you gonna do? Irish, you said a good thing. You said electrons. You could have said protons. Why not? Protons change the atom or element itself. Cool. Okay. Some things we got to know as well about atoms in general. If this is my atom, I taught this first week. We should know this very, very well. No. Z. And let's call it like X. What is Z? Were you that surprised that he found his pencil? Atomic number, what's Z? What's A? Mass number, not atomic mass. Mass number is number of protons. Neutrons. Cool. Atomic mass I've never taught you. Atomic mass is mass relative to 1/12 carbon 12. Guys, what is atomic number? Guys, we've started talking immediately. Guys, okay. In a neutral atom, number of protons is what? Is equal to what? Electron. Not neutrons. Neutrons is neutral charge. We don't care about. Cool. That's what we're going to know about. Okay. Next thing we got to learn. Girls, anything very amusing? If I have an atom, what's the center of an atom called? Where do electrons exist? Okay. Shell is what I'll use, okay? Guys, you call the innermost shell, n is equal to 1, n is equal to 2, n is equal to 3, and n is equal to 4, and so on. Cool? Okay, electron shell configuration. The proper rule is 2n squared. Which means, in my first shell, how many electrons?
2, 8, 8, 2, 8, 8.
According to the general rule, 2, 8, 18, 32. That's a proper rule. Like the official rule that chemists make. 28, 1832. What is my rule that we will use? Huh? A book maybe, Kunj maybe, I don't know. So, the first 20, which means you'll never be asked to do any more than the first 20 in your life. You can't, the rule doesn't hold further on and it gets too hard. And we're going to struggle with the first 20. We don't want to make it harder for ourselves, right? Otherwise everyone's going to fail. Whoever's blowing on their pen, it's Jeremy, right? Are you blowing on your pen, Jeremy? Irene? No, I'm asking, he was blowing on his pen, right? Who's chewing? No one else is chewing on the back of the pen except Jeremy. Jeremy, please don't do it if it was you, okay? If it wasn't you, I apologize for accusing you, but... Okay. Guys, rules to know. Fill in from the first shell. First inner shell. That's rule 1. Girls, if you want to talk, please do it quietly. 2 is, second rule is, you must fill a shell fully before moving to the next. Girls, we don't have to touch each other at high Q. Like, it's not, okay. So, sodium, 11 protons. How many electrons in a neutral sodium? Can someone tell me if you arrange sodium into 2882, my first shell can hold 2. My second shell can hold all 8 because that's only 10. Third shell can only hold 1. That's my electron configuration of sodium. Guys, chlorine is 17. How many electrons in a neutral chlorine? 17. Aryan, arrange 17 into 2882. Wait, that's quick, good. Guys, I'll give you guys 5 to do. You do the 5 and I check if my answer is right. I'll give you guys 3 minutes. Oxygen has 8 protons. Argon. Find the ions of all of these.
Ions of the configuration.
Electron configuration, sorry.
Can we go 288?
Guys, don't pull it out, write it down. Chris, write it down. Guys, stop talking. Boys, don't, if the person next to you know it, fine, no one cares. Sam, do it first. RT, please do it. Stop talking to the person next to you. Guys, for now, Aaron, stop talking. If you're done, well done. Chris, stop talking. Girls, we done? We are? Freya, tell me. Oxygen. O2, no, I want the electron configuration. Boys, tell me, how many electrons in a neutral oxygen? 8 electrons. So you have to do 2,6. You have to fill in the first shell before moving to the next. What about for argon? Good, because it's 18 electrons into 288. Calcium, how many? What about carbon? Electron. We have to be very, very. Are we okay with that? Vivian, are we okay with that? All I'm doing is I'm arranging how many electrons in a 2882 filling in the first shell before moving to the next, and it fills in the lower shell up. How can I hear so many voices, everyone's whispering? So, that's how you make ions. No, sorry, that's not even ions. That's electron configuration. Okay, ions. Why are ions made? What's the point of gaining or losing electrons? To get stability? To get stability by getting a full outer shell. If you have a full outer shell, you are stable. To get a full outer shell, so you're stable. Cool. No, I was going to ask him a question. So, tell me, is this a full outer shell? By the way, for those who don't know what outer shell means, it's the last shell the electrons are existing. Is this a full outer shell? To make it a full outer shell, what two things can we do? Or minus? What is easier to do? Plus 2. So then, do you read I'm gaining 2 electrons? I'm gaining 2 negative things. What's my charge going to be now? 2 minus, not positive. I'm gaining negative things. Therefore, my oxygen ion is called O2 minus. Take a look at this, argon. Does argon have a full outer shell? Does it have an ion, therefore? No ion. If you realized, argon is a noble gas. All noble gases have a full outer shell. Okay, guys, calcium. Guys, the trick is this. Calcium and potassium do not have a full outer shell. 2882 is according to my rule. If we realize what it would have been in the fourth shell, it would be 32. Technically, I'm doing subtract 2 or gain 30. Just remember, potassium, which is 2881, and calcium, which is 2882, will always lose their electrons. I lose 2 electrons. I lose negative things. What does my ion become? 288, so what's my net charge? How much positive? Cool. No. Gain 2 versus lose 2, I'm taught. I'm going to teach now. Guys, you have a question? If you have a question, let me know. Girls, don't be scared to ask a question. Half of you aren't even paying attention. You're already inherently better than half of me. No question? Cool. Guys, carbon 2,4. A full outer shell would mean what? Guys, a full outer shell would mean what things? A full outer shell means 8, agreed? So you're going to gain 4 or lose 4? Off the phone. Alright. So, which one do I pick? Any. You could write 4 plus, you could write 4 minus, but I will always write 4 plus / 4 minus. Guys, let's do one more because you guys are struggling. Nine protons? Find the ion by don't call it out. Write it down. Sam, write it down. Chris, I don't care if you know it now. Yes?
What's the sign?
Boys, stop talking. Get that. Alright, guys, if you lose 2 negative people from your life, do your life become positive?
No, it doesn't.
Okay, Chris. They pause the recording for this. Alright. So, boys, our turnaround. Tell me I'm now looking at Chris's work. Give me the electron configuration.
It's like 2, 8, 2, 7.
Good. Together, full outer shell, what two things should I do? Electron. Okay. Or if I add one negative electron, what does my overall charge become? I'm adding negative things. What do I become? If I'm adding negative things, do I become more negative or positive? Good. How many negative am I adding? How many? So yeah, just get C on minus. Or if you've got to do way more practice.
Why is it CL?
Guys? Oh my gosh. Guys, I'll tell you, fluorine is 17. RF, no one else. RF, tell me, what is the electron configuration?
2, 8, 7.
Good. I'm adding negative. Good. Cl negative. Good. Guys, that is ions. Be familiar with that. Christian? It's implied. At this rate, yes. I mark it. Yes, of course. I marked your guys' test on the plane last year. I'm happy to mark it between my studies. Too easy. It was on the plane to LA though. This is too easy. So, guys, stop worrying about me, worry about yourself because no one knows this yet. So, that is ion. Guys, on that periodic table, guys, tell me, approximately, where were the metals on the periodic table? Middle and left. Guys, tell me this. RF, no, Chris, stop it. You don't need it. Where are the non-metals? Okay. Guys, tell me this. Is oxygen a metal or non-metal? Calcium? It's a metal. It's on the left. I'll tell you. I'll tell you non-metal. Guys, tell me. What do you recognize with the ions of non-metals specifically? What do you recognize? Good. What I'm trying to say is this. Guys, no one's sitting here next week. Girls, you guys can say. Boys, none of you sitting here next week. You talk throughout the entire lesson. They talk as I speak right now. You were really, really good in year 7, I remember. Or year 8. We had no, yeah. No, I'm just saying in general. And now what happened? So you haven't talked today. Confidence in his voice was shook me, Stephen, didn't it? So you haven't talked today. I apologize. I spelled fluorine wrong. I did realize that, yes. Guys, okay. Non-metals, positive, non-metals, negative ions. What do metals form? Cool. Very important to know. Okay, very, very important to know. There's a reason behind knowing this. Guys, to form a negative ion, Stephen, negative ion. Do I gain or lose electrons to form a negative ion?
Oh, you get
To get a positive ion, what do I do? Can these be coupled in any way? Can I couple losing and gaining in any way? What happens if I lose and those lost electrons go to the thing that wants to gain? That is what an ionic compound is. Ionic specifically means this is why. You're actually one of the better students. So I don't know if you're paying attention, but that's beside the point really now. Okay. Non-metal and metal. Guys, give me an example of an ionic compound. Brad, give me a very, very basic one. Hydrogen is a non-metal. Oxygen is a non-metal. What do you eat, Krish? That's like elemental. It's like a seasoning. Come on. NaCl. Thank you, Arian. Let's see how this is made. Where's the metal in this? Sodium or chlorine? Guys, find the ion of sodium. I'll tell you sodium has 11 protons. Find the ion. Do not call out. I don't care if you know it. Do not call out. You're done? If you're done, find the ion of chlorine. Chlorine has 17. Well, if you're done, I'm going to show you why they bond like that. RF, tell me, what is the electron configuration? Good. Good. What's my ion going to be then if I lose negative? How many plus? Good. Do the same with chlorine, RF. Good. Gain 1, so? Good, very good. Okay. Guys, initially, sodium has how many in its outer shell initially? 1. How many does chlorine have? 7. Both want to get a full shell. RF told me sodium loses 1, chlorine gains 1. Sodium loses its electron and chlorine gains it. Hence, sodium just gets the full outer shell. Because there's nothing in sodium's outer shell now. And then chlorine now has a full outer shell. Because chlorine has just gained that electron that sodium has lost. It is, yes. And then, by the way, you agree this is now a positive? Do you agree this is negative? Do positive and negative attract? Hence, you have NaCl. Guys, convention, give me a second. Convention also says you write the metal first.
One of the grids that you have, that's how I.
And by the way, if you decide to zoom in to sodium chloride like really, really far in and you see how it looks, you'll see this. You'll see an Na plus. Cl minus, Na plus, Cl minus, Na plus here, Cl minus here, Na plus here. Sorry. You are correct, Arian. And Tom. Huh? I thought you could have been talking. Guys, you call the structure a lattice, okay? Again, not very important now. That is forming of ionic stuff. Guys, we got to do more in the last 10 minutes. More. By the way, guys, let me teach you how to name it. Guys, naming is very, very easy. This is it. Guys, this is what's up. Naming ionic, you write the metal, you write the non-metal, you get rid of the end of the non-metal, and you add an I. What I mean? For example, sodium, chlorine looks like this. I get rid of the end and add an I. I get sodium chloride. Let's do a lot of examples now. Guys, I want to make magnesium with chlorine. Good. Find me the chemical formula for magnesium chloride using ions. You gotta find the ion of both and you're gonna combine. I'll give you everything, don't worry. I'm not sure. I don't think so. I can give you some stuff though. So, guys, my question is this. You find the ion of both and you name them with magnesium bonded to chlorine. You got to MG what? Chlorine. How are you getting oxygen? No, sorry. MgO is correct. Name it and write it down. So, this is what's up. Magnesium. Arif, tell me electron configuration. What's the ion? Good, Arif. Perfect. Guys, same with chlorine, please, Arif. Good. Guys, perfect. Guys, when I combine them, I want the net charge to be neutral. That is wrong. Why? Because I'll have a resulting positive charge. What do? I what? I double it. You name it, name the metal. Get chlorine, get rid of the ene and add an I. Chloride. Guys, let's do the same thing for combine Mg with F. No, actually not Mg. Combine sodium. No. Combine calcium with F and then name.
What's F?
I'll tell you. Give me a compound with calcium and fluorine by finding the ion of
And then MgO.
and name it. Write it down and name it. Boys, are you doing anything, class? Are you doing anything? Calcium becomes triple. Everybody answer this. Guys, calcium. Guys, one thing. I told you. Boys. Can I see how this work, boys? No. This question. Wait. Do you guys it in your head? What's the answer? Boys, any of you two. In fact, boy on the left, you tell me first. Cool. The other boy, tell me next. Why are you looking left? I'm talking to you. No lie. Just say next time. I don't want to pay attention. Sam, I told you if it's magnesium or calcium, then calcium and potassium, 2882, the outer shell is not full. It automatically just loses 2. Arav, tell me, what is electron configuration? Arav, what's the ion? I have to minus 2. Good. Good. What's next? Good. Girls, cut it. Good. I want to put these together. Krish, can I just put one with this and one with this? Why? I have +2, -1. It's negative and positive. How many fluorine do I need? If I put this, that's +2 and -1. I'll have a resulting positive charge. That is wrong. I want it to be 0 net charge, Krish. Good. Guys, what do I write? Do I write this top or bottom? Guys, bottom means 2Ca and 2F. That is wrong. We want this. Krish, name it.
Calcium fluoride.
Good. Fluorine. Guys, difluoride is only for naming covalent. Are well done. At this rate, everyone's failing minus like Aryan and like Rod or something. Because he's done it in school. But Sam, you messed up calcium so many times. After me saying it like 3 times. Guys, one more, then you guys can go. No, I don't know. How are you even exhausted if you haven't paid attention?
I haven't done it.
Guys, do this and you guys can go. Potassium. In fact, okay, I'll ask a random person, and if they can get it, we leave. If they don't, we do one more till someone gets it. Going to you.
My bad.
What else? Then you reckon you can do it? Guys, okay. Random person time. Guys, okay. 3, 2, 1. Cross. Okay. Guys, okay. Cross, tell me. What is Frost? I'll help you. Boys, cut it. Frost, what is the electron configuration of potassium? Electronic configuration of potassium. Guys, he's getting it. 2881. Well done, Ross. Guys, hey, Ross. Guys, you're not going to do this.
Sorry. There it is.
Ross, the question's yours. Ross, you want to make an ion. You want a full outer shell. Right now, there's one. What can you do to the one? I don't want the one. I can lose it. If I lose one negative for Ross, what does my overall charge get? I'm losing negative. Good. I get K plus. Metro, this one's all you. Metro, give me the electron configuration. 2,6. Guys, next week, no one's sitting here. I'll come in, I'm going to rearrange every single person.